the things that I...
Go on.
Okay, so do you want to do intro?
Kamil and I are discussing the first steps for our pod's proposal two, which is to work on decomposing application settings and sharing it across two pods, as well as figuring out what we need to change in GitLab to support the workload of creating a second group on the second pod. And Kamil has a merge request for the application settings part already. So
Okay, so I'm not sure if it's really like beneficial for us to talk about this particular MR because this is more like just getting this class of errors and fixing them. And it seems here
so
that we are mostly aligned with what
yeah.
we want to achieve there. It's just more like getting this to the working state. Um, should we go back like to our discussion on the proposal too that we had in this issue? Maybe this is like much better target.
Yeah, I need a link to that, or I'll try to find one. What's the issue called?
F24 Q1 planning. Let me link you. I think this one.
Yeah, I got it now. All right. What was the latest? I mean, one thing when I looked at your merge request, okay, so let me share that. When I looked at your merge request, which I'll open again just for the sake of clarity, I think, the one disagreement we were, no, this is not the right one. Oh, this you just linked to another thing. Um, When I looked at this, you had GitLab main cluster as the GitLab schema. And I think that was like the only thing we were disagreeing on was whether it needs to be GitLab main cluster or GitLab cluster. And when I look at this merge request, I can see that it is really just a naming difference and it really shouldn't matter too much what we were disagreeing about. So I'm happy to go with main cluster. The only reason it'll end up being different is if we introduce a GitLab CI cluster, as then that changes how I interpreted what would be eventually deployed to production because I wouldn't have thought we were actually ever going to share the connections between the pods. And I realized we could figure that step out later. So I don't think it's necessarily productive for us to debate the sharing connections between two pods thing or actual decomposition. Because I think once we get to making our plan for production, we can make a decision on that. But I also don't think we'll end up with a GitLab CI cluster because we haven't really talked about any tables that really need to be shared between the two pods, except for like maybe runners or instance variables. But I think those things can also be resolved in separate ways if we get to the specifics of them. So like, instance variables potentially might be debatable whether or not it needs to be shared between the pod's instances, at least in the first production iteration. We could maybe go, okay, instance variables aren't shared because we're not even using instance variables on GitLab.com anyway. And then runners, we that's
We
also
do.
debatable.
I think we do. But whatever. I think like I agree with you. Like we this will be probably like a single target, and like we don't need to care about that until it's actually like a problem, and it's not a problem at this moment.
Right. So I'm okay with go
Uh,
with this plan and this naming convention. And if that's the case, then what
the,
else
the
do we have?
the only I think the difference that we have is like you said you were focused on the feature set where you said like we have GitLab main, then we have GitLab users, GitLab roots, and whatever else that may be shared. I'm kind of saying that like we'll have to migrate things out of the GitLab main into a schema that is very clear, indicating that this is like a pod local. So I mean, in the model that I'm kind of like saying right now that like the GitLab main is like very wide in a definition, but over time you would be migrating that into two types basically. Every table would be classified. It would be GitLab main pod and GitLab main cluster to indicate where the table is actually like located in terms of the data affinity. So um, I think this is like the main difference between what you are describing, because in your case, it assumes that GitLab main is effectively a pod local, and everything else is like in these feature specific tables. And I kind of like, I'm not sure if this is gonna like how we're gonna reach to that, because like the outcome probably gonna be the same, but I think like to approach that iteratively, we're gonna have to go through intermediate schema name to indicate that something is like GitLab main, which is like undefined about the affinity, GitLab main pod, which is like defined to be a pod local, GitLab main cluster, which is defined to be cluster wide, which can then like be renamed to whatever. So I think this is one structural difference between what you're describing and what I'm kind of envisioning.
Yes, it definitely is. So, what is the practical difference, though? I think the practical difference is that the tooling will need to understand this concept of undefined, and we need like what are you trying to accomplish by doing that? Because the only thing I can think is that you're creating sort of a third state where things are undefined. So like rather than it being two schemas, GitLab main and GitLab cluster, you're saying it's going to be three possible values, GitLab main pod, GitLab main cluster, or GitLab main. And this actually implies that something is undefined. And for something to be undefined, that means to say that our tooling sees that as a special case that could either be this or this, and therefore is a little bit more forgiving to how it works.
Yes, and actually I have way simpler way how to handle that in a in a kind of way that like makes our tooling to not have to change at all. And this is another MR that I opened. I was thinking about the approach that like so far we have GitLab main and GitLab CI and whatever. You should be looking at the last comment. Sorry, I see that it's like I got rebased. I I don't know if like the name inherit schemas is like the valid word, but the way how I was seeing that was that like in a case where your query uses GitLab main and GitLab main cluster, it means that like this query is not undefined yet, because it's defined that like your primary context of the execution is like GitLab main cluster. If your query right now is uses GitLab main cluster, and GitLab main pod, it's like a clearly conflicting sequence, which is like you cannot cross join between main and cluster and a pod. So I was and I like the reason for doing that is that like you can assign to users table GitLab main cluster, and you can assign to groups table GitLab main pod as an indicator that this is like a pod local. And technically, the idea is like it should allow you to use that in every place where your query uses GitLab main and GitLab main pod, and contrary and like similarly to the cluster, but it should not allow you to that where you may be accessing pod and cluster context. So I kind of thought this as like an iterative way of solving table affinity, because you may target a single table at a time instead of having to find all tables in a bag that should be like tied together and allow list all cross joins in a code base that are allowed, or like whatever else. It's a hypothesis that it's easier. I did not test that. This is like the hypothesis in my head that like if we start with just marking users and groups, it should give us like very small list of the violations that we can fix and focus on interactions exactly between these two tables, but not between users and user something adjacent, let's say, I don't know, personal access tokens yet, because this is not relevant at this point. But for us, I think like at this point would be important just to focus on interactions between users and groups table. So the idea behind that is like simply allow us to be very selective and have like a very small list of the violations, because I was thinking that like if we record tables being touched by the group create service, we could only focus on classifying these tables and fixing violations only for these tables, but nothing else yet. And technically, this should like shrink the problem to something smaller, and then we could iteratively work on other tables over time to define that, let's say, affinity. So this is my hypothesis that should make it easier, but I did not yet get to trying this out, so I may be completely wrong. That's why I kind of was thinking that like having this third state where something is undefined or like defined based on the context. So if you use main cluster, you basically work in the cluster context and it's completely fine. If you use pod, you work in the pod context, it's completely fine. Would be a way to sidestep having to classify a significant amount of the tables at a single time and have a ton of cross joins and other violations.
Okay.
So if you look at the table schemas out of the query, but I mean it's not complete yet, and you have queries like GitLab main and GitLab main cluster, it's gonna be wind to just be returning GitLab main cluster because GitLab main cluster is like a most specific scheme out of the rule that is defined in that.
Hold on. I didn't understand that last thing you just said. If you have a query that uses GitLab main and GitLab main cluster from application settings, join namespaces. No.
No, this is wrong example. Maybe just do namespaces joins projects, for example, because okay, it's gonna be more like a pod local, but we assume that like namespace is gonna be GitLab main pod.
Yeah, for namespaces, and then the other one GitLab main.
So like projects is currently in a GitLab main, and namespaces is in GitLab main pod. So right. the only relevant information for you in this case is like that this is GitLab main pod. Because this is the most specific context that you are working in.
But okay. Yes, I think I get that, but what I'm confused by is how that's different to what you said earlier, which is like, so I was trying to summarize what you were saying before. It's like, if you have a query that uses GitLab main cluster and GitLab main pod, that's bad, that's an error. If you have a cluster that uses GitLab main and GitLab main cluster, that's fine. Is that this thing here, isn't that just restating what you're saying here, but phrasing the consequences of it differently?
Yes, it's exactly the same, but like the second case is basically by example. That this query would generate this word, but like out of that specification, you just receive GitLab main pod, nothing else.
Receive for what though? The terminology you're using, like for this, the only relevant information is GitLab main pod. To me, that doesn't translate to how I understand what our tooling does, which is it raises errors for the list of schemas that violate. And so that's why like this terminology, I thought they threw me. Is like, are you talking about a new thing? Like, where does this go?
So let's say that in this particular example, this query will just return you a GitLab main pod.
Will return you where?
If you call table schema on the PG query with the tables, it will just return you GitLab main pod. Without this change, would return you GitLab main pod and GitLab main, which in a lot of our tooling would indicate that you are doing cross joins across two distinct schemas.
Sorry, no. Tables to schema of namespaces, okay, and projects would result in GitLab main cluster.
Pod, in this case, sorry.
Oh yeah, pod, yeah. Okay. All right. And now I get how this relates to our tooling, because everything else uses this method, and therefore this would not appear to be a multi-schema violation from the rest of the tooling.
Exactly, and also it would not be like a let's say cross-join, foreign key, and some other stuff related to that.
Right. The foreign key also would have said, is it okay to have a foreign key between these two tables? and it gives back GitLab main pod. Okay, so that's fine. It's just one schema. But that's not really how the foreign key test works, I think. But whatever, that maybe is just an implementation detail.
It works like that, exactly.
Oh, okay. Well, that's good news then.
The only case where it's not yet implemented in this MR, and I just realized that it's like cross modification, but like you can see like how I did it like for this particular case of the table schema, but this is something like to fix it. I just thought about the simplest implementation today, so
Okay.
it's like not fully tested in all cases.
Yeah, the cross modification does work a little bit differently than the other ones because it's keeping state and throughout. And
it's basically like union of all observed schemas. So what I'm now doing in the case of the table schema would have to be added to the cross modification as well, as the same way of seeing that. Like if you see GitLab main pod, the GitLab main information is no longer relevant. This is exactly
right.
how it is
And
implemented.
okay, right. Because you can't just keep building an array. Because at one point, if you just called this with projects, you'll get back GitLab main, and then therefore your array will now contain a GitLab main, which you don't want it to. Later on, you want that GitLab main to be overwritten by GitLab main pod.
But this rightfully would raise an existing exception in a case where you see GitLab main pod and GitLab main cluster, which
So
would be for tables that are already classified by us.
yeah, you could have like some kind of, tables schema set class. And then, if you have a new one of those with GitLab main and you add GitLab main cluster, then you will get back this GitLab main cluster in the set. Something like that.
Something like behavior is like that. It's like implementation is simpler.
Yeah. Okay. Sure. So then, okay, we this works most places except cross modifications builds up array of schemas over time, and this needs to evict GitLab main when it sees a more specific GitLab main score.
Yes, that's the idea basically behind what I'm doing.
Before detecting violations. And that still needs to be added to this merge request. Yeah.
Mm-hmm.
Okay. But you're doing that anyway, so okay, that's mostly underway. Yeah, I can't see any reason that this is demonstrably better than how I was imagining us tackling this work. I'm now it's much easier for me to say that because I fully understand what you're actually implementing. And my kind of criticism before or concern before was less about whether or not it was a good plan and more just about the fact that I didn't understand the plan. So I couldn't even implement it before.
I think like the outcome is like what you are saying. You actually like focus on doing significantly more at a single time, because it's still like compatible. What is being here is just, let's say, much more granular
Yeah.
than what you are proposing. And like everything is less is just like a naming convention, but naming can change. So
Yeah.
I'm not
Well,
worried about it.
I think like your approach maybe has an interesting, I mean, I'm skeptical, but there's maybe like a middle state where we end up like defining enough tables and we go, okay, actually that's a good enough pod. And we deploy the second pod and it's like a second pod that has some features working and some not. Like I'm skeptical that we'll get to that, but I think that is the theoretical benefit that most people want to accomplish. But like we all want that, but we don't know what that looks like.
I don't know if this like the last statement is true. and it's gonna be true. I'm kind of think more that before you can deploy, very likely you still need to probably like classify most of that. But the tricky part, like how you get like to the critical mass that you can confidently classify what is rest. So that's why it's suggestion. So I mean, like in the end, I think we should figure out that we have everything classified. Just like it's a very bumpy road to get to classify significant part of the tables. So
Yeah.
that's
Okay. Well,
that's the idea to like to iterate on something smaller initially. It can be true as well.
I think basically it's, it'll be a matter of, a fact of how we learn how this actually plays out, whether or not it ends up being a simpler way, a model to get to the full list of tables or not. The pretty much the only advantage of the way I was thinking about it, that I still think is an advantage, is that it's a sort of more kind of a path that we've already gone down before. So it's a strategy we've already used before with CI. But you're rightly pointing out that probably the classification problem here is more difficult than it was with CI. With CI, I think like we had all of the tables except for like 3 of them classified right off the bat correctly, and the only different ones were like taggings. We had to learn that goes in CI, and 2 other things. I can't remember what they were, but like
external reference, external merge request, I think, or something like that.
Yeah.
There were like tagging stacks, and I think external merge requests.
And then there was the only like the debated ones were environments and deployments, but we kept them in main.
In main in the end. So
yeah. So given that you're right that probably was a simpler decision than what this will be, I think you're implementing and this is updating our tooling to handle this special case. And I think it's fair to say you've thought of a kind of simple way to do it that's probably going to end up being like under 100 lines of code changes to our tooling.
50.
Under 50 is the guarantee.
No, it's not guarantee. Like with tests, it's probably gonna be 100.
Okay.
But that's the idea.
Yeah, so I think it's fair to say you are updating the tooling, because you said that we didn't need to, but we do. It's just a simple update, and I think that's fine. And now that you've explained what it will be, I'm okay with that.
Like in any case, we would have to update tooling because of some hard code that GitLab main and GitLab CI. I think
sure.
3 or 4 different places where we hard code that. We also hard code that, I think, in the application record, where we do GitLab connection stack, sorry, GitLab transaction stack. So
yeah, I mean, but that's one update versus 2 updates. So it's like it's an extra change to our tooling. Yeah, but okay, cool. Then if we talked about that, I can try to find a better place to actually write this. But then other than that, what would be the next logical step? Kind of has something to do with users, which I think you already defined pretty well. And maybe I don't have any questions about. It's like put users and namespaces in a well-defined different schema and see what happens.
Yes.
When creating a
A
group.
lot of things gonna be break. A lot of things gonna break. So maybe it's just good enough, let's say, to specify one of those. Let's put users just in the GitLab main cluster and see what breaks. Nothing should break, basically.
Nothing should break because there is nothing in GitLab main pod, so it's not actually possible for it to conflict with anything.
Okay, but no, I think like what you could do differently, like put namespaces into GitLab main pod, because technically it can break with the existing application settings. But application settings, if we ship that, it's still gonna be before like this tooling is put in place. So
right, but it's because you've already done application settings. You've already removed this loose foreign key, and there was no joins. But there's only possibility would be left would be cross modifications that could possibly break. But yeah, we could start with namespaces. We'll have the same problem with users though, right? Because users in that.
Yeah, so basically nothing should break with the application settings, and then you're specifying namespaces, but like it's gonna be a bunch of things broken with users and namespaces. I'm pretty
Right.
sure.
So that would likely be the next meaningful step, putting
Yeah.
those things in different schemas.
Putting those, maybe even like allow listing everything, like foreign keys, cross joins and cross modifications initially, and then like kind of figure out how many of those are, and if they, even if this is viable path. Because I'm kind of like worried that like I don't know. I'm worried that like this is gonna be long, and I don't know how long it's gonna be. That's my worry.
Yeah, well, this is, I mean, this kind of follows the same discussion we had the other day, which is we know that there are a good number of risks, and we want to pick a path that mitigates those risks as early as possible, highlights the severity of those risks as early as possible. I have like this
So like
users, but yeah.
like one interesting risk is like with my comment about the application settings, having cross noise to things that are used for
Yeah,
the authorization and things that are used for the templates.
I don't really get why that'll be a problem. Like you have these foreign keys that can be swapped out, but like it's pretty simple, right? That the fix to that problem is simple. I kind of I'm not even sure it's necessarily bad database design the way we have it. I'm sort of okay with the database design we have there, but I don't really get what the problem is remaining
uh,
other than fixing this.
it's not about the foreign keys. It's about like namespace is gonna be pod local, so how it should behave if you have many pods.
Oh yeah, no, okay, yes, right. Of course, it doesn't make any sense for us to say that the entire instance has this group as administrators when that group doesn't actually exist on all the pods.
So,
Uh, I didn't actually
but
think
but
that
but
through.
the same is like for the templates. You're not
Yeah, say
gonna
the project
easily
templates.
accessible info. So I don't know, is it really like a first intro cluster type of the feature that you kind of need to implement?
Yeah, this is, well, I mean, we talked about early on how some parts of application settings may need to have an application settings table that has a row per pod, and that this may be the first example of where that's necessary.
So
That was, yeah.
I think that this is one of the things that shows like potential risk of like how it should be solved. So because like technically like if you set up pod 2, just the lack of that entries, it's still gonna make application work. It's just gonna make it work slightly differently because some administrators will not have access to the pod 2, and some templates will not be simply used.
Yeah, I think it's a pretty good kind of product question to start with. Say, like, look, we started very small with application settings, the very simplest table. It has almost no joins and very few foreign keys. Now we have two teams that own this feature and a different team that owns this feature, and we can go to them and say, what do you think should happen in the pods space? And
Would it be
like,
local to a pod? Would it be moved to the organization? Would it
well,
be
but
intra-cluster type of the feature?
yeah, I mean, I think we'd have to kind of put some constraint and say, look, we're definitely not okay with all the pods being able to access this directly, but the template project directly, but we're okay with you rewriting the feature so that it's makes requests across the APIs when it's needed or something more elaborate, but it's a much more difficult feature to maintain. Would you implement it that way, or would you just say, go ahead and have one per pod and just implement it that way? Um, when do you think is reasonable to actually start asking that question? Since we've already discovered this now.
I would get like this probably like March 1st when we have something. Okay, and I don't have some opinion like when we should start discussing that, but this is like probably soon.
Yeah. Yeah, I think, well, I mean, I think that's, we're just talking about if we're trying to de-risk product aspect of it, then that's kind of question we need to start asking. And yeah, I think you're maybe also thinking like we should build up a massive amount of examples before we start asking the questions, because then it will show the magnitude of this problem to be solved. So let's say you end up finding with users and namespaces like 200 examples, and then we can describe 2 of them and say, look, let's work on and focus on just these 2 of them and figure out how much work that would be and multiply it by 100. And that is at least the scale of the problem we have to solve. Maybe partly how you were thinking about how we get from where we are today to understanding the scope of this work.
So, I mean, like, at least in the case of the application settings, is that we can probably like describe that pretty well, like what is happening and what would be the problem and like what would be the barrier. And then simply ask in each case, can we simply ignore this problem? What will happen if we completely ignore that problem? Will application break? And like tell us if this is like fine. Because I think not all of these problems have to be solved. At least like this one that we have here, I'm not sure if this is essential to solve, but like I think it's like essential to be aware that this is like the problem, and I'm just kind of curious like how many of such patterns we're gonna have. Because technically at some point we should have very predictable patterns of these problems. So
yeah, I think it sounds like your preference is to keep building up a list of the problems before we go to ask people what we would do
no,
about those problems.
I'm not saying that like we should be it. I think like it's probably like a completely valid approach to do it once we go and like figure out these problems, because then we like engage like very targeted group of people specifically, and it also kind of like builds our knowledge how these teams react to this type, and like what would be their idea to solve that. Would it be like dismiss a fix like an intra cluster or like a pod local, because then like it could be like if we have like this easy problem solved, it can be like you probably have like a guidebook to other type of the features. Hey, like this is how we solve these pure features, or like this is the design that we are implementing. Is it something that is like you could replicate? Is it applicable for you? Because like I think one thing that we would like to avoid is like having many distinct solutions. I think we should kind of say either we are not solving and like we make application to work without that, or we are solving that like in like kind of templated way across the board. And basically like we have I don't know, let's say 2 or 3 different paths how it can be solved, and maybe we can fit all of them into that. So sorry, I'm kind of saying random stuff because this is also a very random problem, and I don't know how people from these teams would react to this very random problem and how they would like to solve that if they are
What you
asked to
yeah,
solving that.
what you said makes a lot of sense to me. I think my preference based on what you described would be where you've got the application settings things to merge and the tooling improvements to handle undefined schemas. And we have that list of 5 things. I would prefer that, okay, in parallel to the development effort, we actually start to take those identified things to product managers and get them to describe what they think the impact would be for the feature and whether or not they'd find it acceptable. And the development teams, if there's something else we missed. At the same time, the development work continues with probably meaningfully we have to put users and namespaces into a separate defined schema, and then basically maybe we can do in parallel have multiple of us going through and allow listing hundreds of examples, or one of us could do all of the cross join analysis and another do all of the foreign keys or something like that, and start to add them to allow lists, and then start to fix some, and then once we fixed a few, start to delegate other fixes. But yeah, I think that what we need to be happening in order to be most efficient, like we need to be constantly in parallel trying to highlight the scale of the problem and the kinds of problems that we're having so that we can, de-risk something early and go, actually, there's an element of this plan that is problematic and we need to actually adapt to that early and not implement a whole bunch of things that's just too much work. So
I agree. Like I'm curious, like how gonna be reception from the teams on those.
yeah, I was so Nick already put that in the thread, but we already have CID composition as a list of top priorities for all teams in the company. So we're changing that. We're trying to rename that section of the prioritization handbook to say pods. And that will kind of help us have the conversation with the rest of the company about, is pods actually still a top priority? If Sid thinks it's a top priority and it's still in the prioritization framework, then other teams will just have to work with us on this stuff, as frustrating as it may be. And then that can also allow us to have the conversation about how viable this really is.
Okay, so this is something. I actually have also like another parallel topic about the approach that we are taking with database level sharing of data. And sorry, it's just my random thoughts that I'm gonna be giving. I don't know, like if basically like I found like the current approach like fairly problematic because of, let's say, the stability and like the fact that you can very easily break pod one. But I also don't know like what is like the best way to move forward with that. And like let's say like the less risky and like something that we can actually do. I was thinking basically like there are probably like few different ways. I don't know how many I'm gonna like mention. Basically keep it as is, like you have a cluster wide database to each pod can write. Second, which is like you have cluster wide database to which only a single pod can write, and every other pod has to read only. But in order to apply changes, it has to go through well-defined API. And this is probably like a very similar to approach number 3, where you have like a very dedicated service that gives you like a very stable access to the cluster-wide data, which is like not database level, but maybe this is more like like an API-based type of the access.
Okay, I was trying to follow you and also try to find a place to write this down. So first approach would be the direct DB access.
DB access with just read and write, basically, pretty much what we have right now.
With read, write, as described above, implies risk of corruption from another pod.
Yeah, because every pod can modify everything pretty much.
Implies risk of corruption and stability from another pod, instability. Second would be well-defined API for sharing, and that was kind of where.
So I think like the second approach that I was thinking was be like an async DB access. So async in a way that like each can read, but only to perform writes you need to do like a well-defined API.
Now, what does that API look like? It involves queuing a sidekick job for pod 0 to do the write somehow.
I don't know how it could look like. It could be like even, let's say, a separate service, or like it could be like a responsibility of the pod one. So let's use pod one. A responsibility of the pod one, or like it could be like a separate service that only has like a write access, and every other access has to like write access has to go through that API. Like a single, like a let's say a use case would be user logins, and you update user activity timestamp. Another case would be you create a group and you want to ensure that this name is unique, so you create like a global entry in roots. Another example, maybe you modify like a user profile settings.
Okay, I am trying to think that one through. The first thing that stands out to me is like it's pretty similar to saying that we're doing a shared service rather than a shared database, with the twist that you can actually get direct database access for reads only.
Almost, because like in the shared service, you also have to have like a read API, which is like you have to completely change all of the existing data model that you have with models that you are accessing. So I guess like it's more like a take your bullet type of the approach in terms of like the amount of the changes that you have to do.
Yeah, I'm kind of my instinct is
So
that mixed approach is probably more complicated than we would like, but I don't know. Like we kind of went with the pods architecture of, the earlier questions were like, would shared things be in shared services, or would we just share direct access to a database? And then this one is somewhere in the middle of the two. It's like, oh, we'll share direct access to the database for reads, but we'll extract shared services for writes. And I think that sort of, maybe you're trying to balance the corruption problem by saying, okay, with the shared services, but the simplifying the amount of code changes by still allowing all of the existing select queries to work, I guess is the advantage of this. It does seem like a pretty strange architecture that I've never seen before.
but because basically like the third one is like a defined service pretty much that can only read write.
Okay, so one is kind of what we have already documented in the plan. Two is somewhere in the middle, and three is what Grzegorz keeps also mentioning as probably a sensible thing to do, which is shared services that use APIs rather than sharing database access. The other, other thing I think, okay. I don't know exactly what this looks like, but maybe we can explore with it. Kamil, I'm gonna jump off now. I have to deal with something, but I will write up all the conversation we've had now, and we will, come up with a plan and chat about it on the middle of the week anyway.
Sure.
All right.
Thank you for your time.
See you later.